Today on Steve's Makerspace, I feature two Spirograph machines that I built in Scrap Mechanic. One has mechanical arms that shoots out a pattern, the other is electronic and uses math to make a pattern. Hi everybody, Steve from Steve's Makerspace here, and today we are in Scrap Mechanic. We are making two different Spirograph machines. One of them uses math, one of them is more physics based. This is the Spirograph toy, which you might be familiar with. You can make designs with it. It comes with these parts, and I'll show you real quick how you make a design in using the physical Spirograph machine. So you put one wheel inside of another wheel and you just start going around like this. Keep going until you get a full pattern. And there you go. If you look at the Wikipedia article about Spirograph, not only do you find out information that I just shared with you, but you also get these mathematical formulas for how the Spirograph works. And here's another website that has famous mathematical curves, including the Hypotrochoid, which is what I used in my electronic Spirograph, the one that uses math in Scrap Mechanic. There are other curves that are similar. This is an epicycloid, so it has a slightly different formula, but they all use sine and cosine. Sine and cosine are the ratio of sides of a right triangle. So this example proves that the sine of a 35-degree angle is 0.57. Now here I'm in Excel, and there are a couple of interesting things about sine and cosine. So I've got 1 through 360 degrees, and I'm getting the sine of this degree and the cosine of this degree. So if I take the sines and the cosines and plot them on an XY coordinates, I will get a perfect circle. And if I take the degrees as the x-axis and the sine as the y-axis and plot them on an XY coordinate system, I get a sine wave. So here I am in Scrap Mechanic. This is my screen. Now you can see I've lost quite a few frames because this thing is huge. It's 50 by 50 screen with lots of logic blocks. Let me just put it on a lift real quick so you can see how much I've got here. And I'm having to cut out some of this because it takes so long to put on a lift. 11,000 logic blocks. Let's see, 2,500 of these light blocks, pixel light blocks. So this is my perch up there, and where I'm doing all my a lot of my math. And there are only 3 signals coming from that perch. One is a reset, that's the pink one, and then the two blue ones are sending signals for y-axis, x-axis, and y-axis. And then those signals go off along here, and those signals go off along here. And then where the signal, let's say if you get a signal going to here and to here, then that's going to appear on the screen right about here. And so that'll light up the screen in that spot, right? So we'll get up here. And let me get back off. So I've got a section for sine, section for circle. So if you want a circle, you can just turn that on and then get in the seat and start it. And then I've got some other patterns. Here's a rose pattern. This is a Spirograph. Specifically, it's a Hypotrochoid. And then this is a different pattern that is similar to the Hypotrochoid, but the formula is slightly different. As you can see, I'm using math blocks. This is the Mod Pack math blocks from Brent Batch and Durf. If we turn on the circle and get in the seat, You can see I've just got one button, one switch. I'm going to hit the button first to clear the screen. Let me get close up, and then I'll turn on the switch. Now, as you can see, this is quite slow, so I'm going to speed it up significantly. So here's 10 times normal speed. So with the circle, I've got a counter over here that's counting up. There's a clock underneath here that's hidden so that you don't see all the flashing lights. The counter is going to the sine and the cosine calculation, and then it's multiplying times 24 because my screen, if I just did sine and cosine, it would give me a number between -1 and 1, and I don't want that. I want a larger, I've got 24 blocks going this way and 24 blocks going this way, so I need to multiply by 24. And then that final result goes to the screen, right? So now I'll turn the circle off and turn the sine wave on. Let's get in the seat, clear the screen, and start the sine wave. Now for this one, I don't need to change the speed. This is the actual speed. So for the sine wave, I'm taking x as the counter and then the sine of the counter and then multiplying that by 24, and that gives me my sine wave. So let's look at the rows pattern now. So the rows in math has calculation like this, and you can get all sorts of interesting design. So I'll switch over to Excel. So I've calculated this in Excel, and you can see if I switch this to 7 petals, I can go to 9 petals. Now interesting, if I say 5 petals, it actually does, 6 petals. It actually does double that amount of petals for some reason. If I say 4 petals, it's actually giving me 8. So the odd numbers, it gives me the exact number of petals, but the even, it gives me double. So let's do a 5 petal rows in Scrap Mechanic. So we're going to, this is the petals here. I'll turn that down to 5. Make sure your rows is turned on. Let's get that going. I'm going 30 times regular speed here. Still takes a while. So the rows, I don't think I'm going to go into too much detail about how the rows calculation is done. You can see the formula on that website, but basically I'm using the same formula here just with these math blocks. Here's another rose design I did using 4 petals instead of 5. Now we'll get into a more interesting pattern, the Hypotrochoid. So there are mostly three elements to manipulate here. There's this one, which you can change. That doesn't do much. There we go. And then this. And so as you change each one of these, you get different patterns. 3. So this is much more interesting than the rose pattern, I think. 11 and 5 and 12. So the one on the left here is what we're going to see in our machine. The one on the right was actually a mistake of mine, but it's a very interesting mistake. In Excel, you have to convert, you don't just take cosine of this number, you also have to put in a radians formula. If you don't do the radians formula, if you just have cosine and sine without radians in here, then you're going to get this, which is some really interesting stuff. In fact, let me copy some of this over to here, and I can get some really beautiful patterns like this. Let me see this, like that. Anyway, I'm going to put this Excel document and some other Excel documents onto a Google Drive, so if you want to download these and play with them, you can. But this on the left is what we're actually going to get in the Scrap Mechanic machine. So we're going to start with 742, and we'll make this pattern in Scrap Mechanic. So I'll plug in 742 into my machine, and we'll start her up. I'm going 30 times regular speed right now. Now we'll do 451, which should look like this. I've got that programmed into my machine now, so I'll record that at 40 times regular speed. Looks pretty good. Here's 4, 7, and 2.3. And now 5, 2, and 2. 10, 3, and 3. Okay, I'm going to go back into Excel. So you'll recall there was that last formula, the one that said Steve, which is one I made up. I sort of made it up by accident because this is the regular hypotrochoid, but this is not the hypotrochoid, but as something else by mistake. So what happened was I was supposed to multiply by this number here for this one, and then if I was in this one, I'm multiplying by this number here. But instead what happened was I wound up multiplying by this number here, which is 0, and I did that by mistake because of this little $sign in front of here. And what happened then, because this was 0, that made all of this 0 right here, and pretty much none of this was actually being counted. So this is what the formula actually looks like, but it made this very interesting pattern. So this is the hypotrochoid without part of its formula. And so the left is what's actually going to appear on our machine. The right is, again, in Excel with its without that radians formula. This is what shows up in Excel, which is very interesting. So I can manipulate these again. Let's say 7, 1.49, and 3.9. Does that give me anything? And I gotta do this. There we go. So anyway, some interesting things you can do here. And a lot of this I just played with. It was trial and error to see what kind of interesting patterns I could come up with. But let's get into Scrap Mechanic and see what this looks like. So we'll do 4, 1.55, and it should look like this. So here are those numbers plugged in, but I've got the Spiro button turned off and the Steve button turned on. This is at 50 times regular speed. Here's 10, 2, 7 at 30 times speed. Here's 7, 1.52. Alright, so that's enough for the electronic spirograph. Now we'll get on to my other spirograph, which uses physical arms. So this is my spirograph, physical shooting spirograph in Scrap Mechanic. You can see it's just some arms, bearings, and a cardboard wall. One color for the cardboard and another color for the steel in the back, metal to which will not be shot out. And so we're going to shoot out a pattern using the smart engines from the mod pack. So these on the right are controlling the speed of the arms. And this is the arm that's in the center. This is the arm that's the farthest away, and then these are the lengths of the arms. So the arm towards the center and the arm that's the farthest away. There's 3 arms, and I've got the arm lengths adding up at the top because if you do like that. This is as far down as you can go because of this right here. You don't want it to go any farther than that. And anyway, it'll go off the side if it's any longer than that. So that's the maximum you want that at. That's basically all there is to it, and you stick in whatever arm lengths you want, whatever speeds you want. You can have the speeds go negative, which means instead of one arm going clockwise, the other one would go counterclockwise. So we'll start at the first arm, length 20, speed 6. Second arm, length 9, speed 8. Okay, I started the recording of this a little late, but as you can see it's quite slow, so I'm going to speed it up. It's also very noisy, but we're making a very interesting pattern. And here's our final result. And if I want, I can save this as a piece of art. Here's some other numbers I put in at random to see what they would make. And here that is towards the end of making that pattern. Obviously, if you wanted to, you could color the cardboard and the metal different colors. I just picked these colors because of the high contrast between them. Let's do another spirograph with these settings. I noticed it was skipping some along the outer edges, so I thought maybe I'd try adding a second gun and see if that helped. But then it seemed to take out too much, a little bit too wide of a path in places, so I decided that I wouldn't actually use the second gun. But it was still nice. Now for this one, the pattern wasn't all that interesting, so I decided to stop it and reduce the arm lengths and then get it started again. So here's the result of that, and I think it turned out pretty well. Now the wall will be a separate download from the workshop, and then you can just weld a new wall in place once you've finished with one pattern and you want to do another pattern. So we'll do this one next. Notice I've got one of the arms going in the opposite direction. I'm going to speed through this one really fast. And we have a lovely daisy. Now these settings were interesting. It started off as an outward circle, turned into a spiral, and then went to a spiral going outside and then inside again. These settings created a kind of crown, which was pretty interesting. So I want to do one more thing before I finish. I want to see if I can use this to program the Spirograph machine in Scrap Mechanic. So I've got one arm that's going, if you notice, this is going around this way. So it's going in one direction, but this is spinning in the opposite direction. This is spinning clockwise while this is spinning counterclockwise. So the length from the center to this point, the center of this circle, is 12 16ths of an inch. And from the center of this circle to the point that I was drawing from here is 6/16ths of an inch. There are 12 points, which means that this had to have rotated 12 times in order to get all 12 of those points. But what we don't know yet is how many times did this go around this circle in order to get those 12 points. So let's go ahead and redraw it and pay attention to when it passes my finger here, okay? So 5 times it rotated around. 12 and a 5 for the rotation, a 6 and a 12 for length. What we have here is really a ratio. We know that the center arm needs to be double the length of the second arm. So here I've got arm 1 and 2 adding to 18, and the second arm is 9, so it's double, and then the center arm is at -5 speed, and the outer arm is at 12 speed. So here it goes, And I noticed that the left side is kind of pointy and the right side is rounded. I think the bearings and the pistons are both being distorted by gravity on each side. So I could probably improve this using modded pistons and modded bearings. But here's a side-by-side comparison of what we started with and our finished product, and I think we did a pretty good job. Here's a gallery of some of the art I created with my Spirograph shooter. That's going to do it for this episode. If you've liked what you've seen, please like this video and consider subscribing to my channel. And if you're already subscribed, you can hit that bell so you can be informed of when I make more videos. Love to see some comments from you. What did you think? Have you made some interesting patterns? You can give me the numbers of the patterns that you made. The items are available on the workshop. There are plenty of links in the description of this video. That's going to do it for today. Thanks for watching, and I'll see you in the next one. Bye! Steve's Makerspace.